Next we'll work problem 13 in chapter 4, determining the tyrosine content of an unknown protein. A previously unknown protein has been isolated in your laboratory. Others in your lab have determined that this protein sequence contains 172 amino acids. They've also determined that this protein has no tryptophan and no phenylalanine. You've been asked to determine the possible tyrosine content of this protein. You know from your study of this chapter that there's a relatively easy way to do this. You prepare a pure 50 micromolar, not nanomolar. That didn't copy properly. You prepare a pure 50 micromolar solution of the protein, and you place it in a sample cell with a 1 centimeter path length. And you measure the absorbance of this sample at 280 nanometers in a UV-vis spectrometer. The absorbance of the solution is 0.372. Are there tyrosines in the protein? If so, how many? You'll need to use Beer's law, which is described in any good general or physical chemistry textbook, and you'll also find it useful to know the units of molar absorptivity, or molar to the -1, centimeter to the -1. Also, you'll need to look up molar absorptivity for tyrosine. And the reason it's important to know there's no tryptophan or phenylalanine is because those absorb in the same region as tyrosine, and so they will interfere. All right, so let's get started with this problem. So we have a 50 micromolar solution, which is equal to 50 times 10 to the -6 molar. Okay, we know Beer's law, A is equal to EBC, where A is equal to the absorbance, epsilon or E is equal to the molar absorptivity. Okay, I'm just going to write MA. B is equal to the path length, which we are told is equal to 1 centimeter in this problem, and C is equal to the concentration, which is what we need to find first. Okay, and so we have the absorbance, which is equal to 0.371, and the molar absorptivity is equal to 1490 molar to the -1 centimeters to the -1. Okay, so we need concentration, so we can say that C is equal to EBC. So A is equal to EBC. So C is equal to A over EB, okay, which is equal to 0.371, which is our absorption, over the absorptivity, times B, which is the path length, which is just 1 centimeter. Okay, and that's going to give us 2.49 times 10 to the -4 molar. So now we know our concentration, but how do we calculate tyrosines in the protein? So we know that we're going to have n number of moles of tyrosine, which is Y for the abbreviation for that, per mole of protein. Okay, so we can say that tyrosine is equal to the number of moles times the concentration of the protein. Okay, so we know the concentration, so we can say, that N is equal to Y over P. So the concentration of tyrosine over the concentration of the protein. And that's going to give us the number of tyrosines per protein, which is equal to 2.49 times 10 to the -4th, which we calculated previously, divided by 50 times 10 to the -6th, which was given. That's our concentration of the protein, which is equal to about 4.98, which is approximately equal to 5. So we have 5 tyrosines per protein molecule.